Hello there. Vector Podcast is back. Same season three. I think we are about to wrap it up with few final and really interesting episodes. Today I have the privilege to talk to the open source crew, Eric Pugh, who you have seen in the one of the previous episodes, and a new guest, Daniel Wrigley, joining us to discuss a really interesting topic on hybrid search and optimization. Really, really excited to have you both on the show. Hello.
Hey,
Hey,
Awesome. So, as a tradition, we start with the intros. Eric, everyone knows, but Eric, feel free to
yeah.
intro yourself.
Great to be back, Dmitry. I'm a little late getting here because I realized as I was driving to the office that I forgot my mug that you gave me the other year. So I actually called Daniel. I was like, I'm going to be a little late because I got to go home and pick up the mug and bring it in the office. My wife keeps it and we use it when we go hiking. But I was like, I'm going to bring it in the office and show it off since this is my second podcast to do with you and the mug that you gave me 2 years ago, 3 years ago at this point.
Yeah, probably three
Mm.
years.
Works great. Works great. So yeah, super excited to be back here and kind of talk about some of the work that we've been doing with the OpenSearch community. So
Exciting. Yes. And Daniel, welcome. Can you say a few words about yourself, your background?
absolutely. Yeah, thanks. It's great to be here. I'm super excited, maybe a little nervous, but I'm sure it'll be fun. So I'm Daniel. I'm with Open Source Connections. I started out as a search consultant back in May 2012. So almost 13 years now. And I'm here to share some of our experiences that we made in our most recent project together with the folks of OpenSearch when it comes to hybrid search, how to optimize hybrid search, and also what's necessary to optimize hybrid search, namely query sets and judgments. But I'm sure we'll get into that in a couple of seconds.
Yeah. Thanks, Daniel. I'm also nervous, but I also know that, you know, when I re-listen the episodes, I enjoy them. It's just fun, really. So I was thinking like hybrid search, yeah, we did discuss, and I think community discusses it at large in various forums. Eric also reminded me of the episode with Alessandro Benedetti that we just did at Berlin
exactly.
Buzzwords. Um, yeah, I was really just curious, maybe step back from that topic a little bit and discuss the importance of hybrid search and what is it? In your own words, where do you see value for it compared to how we used to do search before?
You want to take it, Daniel, and then I'll follow up.
Sure, yeah. So I think we see hybrid search, especially in this project, as let's say the process of blending traditional keyword search and also, let's say, modern search approaches based on language models, mostly called either vector search or neural search. And I think the benefits of it are probably twofold, or I guess you can group them into two groups. So looking at the end user, we always want to provide the end users with the most or the highest quality results, right? So search result quality is what we strive for. And traditional keyword search always lacks of, let's say, finding related things that may not really contain the specific words, but are similar. So laptop and notebook is an example that I think we ran probably 1 million times in our demos, maybe even more than 1 million times. So if notebook is not in my product description, I will not find it when I search for laptop and the other way around. And that's where, let's say, blending the two techniques really shine because it enables you to not only find where your keywords are in, but also find related stuff to augment the result set. And I think with that large benefit, of course, come a lot of challenges because it always is, let's say, non-trivial how to actually blend the traditional techniques and the more modern techniques. So that's where the challenge between, or the challenge behind hybrid search actually lies. I mentioned two groups for which there are benefits. So the end user, we want to provide the end user with the highest quality results. That's one group. The other group is, of course, we as the ones providing search applications. I mean, we somehow need to profit from providing better results. And it then is always different, or different in which, let's say, scenario, in which industry we are working. So the most transparent one is always e-commerce. The easier the end user, the consumer actually finds stuff in your online shop, the easier it is for them to buy stuff. If they buy more stuff more easily, of course, we generate more revenue, and that's kind of the benefit then that comes with providing better search results. And the other way is we don't want to, let's say, manually tune our systems, let's say, indefinitely. So, of course, I can go ahead and say laptop is synonymous to notebook, and PC is maybe a broader term of laptop, and rules like these. But that's kind of work that is never done if I have a changing catalog that, I don't know, old products get thrown out of the product catalog, new products arrive. So it's a never-ending challenge for me. And I don't want to, let's say, spend my workforce always manually hunting these rules and thinking about what may the users mean when they search for something. I want something that's, let's say, intelligently looking for the right things in my index. And that's what the neural part of hybrid search enables us. So I think these are definitely maybe the two groups that benefit, and how these two groups benefit from my perspective.
Yeah, that's really good intro. Eric, you wanna take it?
Yeah, I
Forward?
think it's an interesting journey that we've been on the last few years, and I sort of look at hybrid search as a little bit of a course correction, right? So keyword search been around forever, well understood, frustrations are well known. And then vectors came out, and all these new products, these new vector databases, everybody was really excited about them. And we all said, oh, okay, let's go use vectors. And we leapt on that and got really excited and built everything using vectors. And I think maybe we went too far that way, over into vector land. And after we started getting some experience with vectors, we started realizing some of the problems with it, right? Like, doesn't matter what you query, you're going to get some search results, right? Sometimes zero search results is the right answer, right? Interesting challenges around, faceting or pagination or highlighting can be weird, right? So, I think that there are some definite challenges in vectors, and we all went over that way. And I think we've seen it in the last 2 years, where all the vector databases were frantically adding keyword-like search, and all of the keyword search indexes were all frantically adding vectors. Yeah. Okay, now we have these things, and it's like, where do we go? Oh, hybrid search, right? Hybrid search. And hybrid search popped out, and hear me out. I think hybrid search is just good old federated search from the late 90s and 2000s, where you had two search engines with you send out two queries, and then you brought them back, and you're like, how do I merge them together? And sometimes you do terrible things like two lists of results, right? Sometimes we would try to link them up together. It's the same idea, whether you're going to one search engine and you're making a keyword search and a neural search and bring them together, or two totally separate keyword search engines, you're still bringing back two lists. However, I think at least this time around, how to merge the lists of results together seems to be going better than when we did it back in federated search, right? And I look forward to talking more about like some of the ways that we bring hybrid, build our hybrid result set together. Part of me really kind of wonders why ranked reciprocal fusion wasn't a thing the last time I did federated search back in the 2000s, right? Like, doesn't seem like that crazy of a concept. Why didn't we do that, right? But we didn't. So I'm a little more optimistic about the value of it. But I think hybrid is a little bit of something old coming back because we're back to the same problem. I literally have two search engines, two concepts for how to do information retrieval, and yet I want to blend it into one.
Yeah, that's exciting topic. I think to me, a hybrid search opens doors beyond sort of what I think Daniel just explained, the semantic connection between, keywords and so on, is where you go multimodal, right? Of course, you need to go there carefully, probably, but if you do miss metadata on a particular, image on the product, you could reason about it using the image itself and maybe also video, because we have video LLMs as well. They're more expensive, of course, to run, but sky is the limit, so to say. If you want to go there, go.
Yeah.
So I think in that sense, hybrid search unlocks many more avenues to explore, including in e-commerce, I think, right?
Yeah. I mean, I love that we are actually getting away from the old just straight up bag of words that was keyword that served us for a long time, but still was just a very rough approximation of what people want, right? I mean, BM25, people say it's not even the best algorithm. It's just as fast as the one that we use. Vectors is sort of this idea of there are richer ways of understanding user queries and the content tech, and just going beyond text is absolutely wonderful, right? Lots of different things. I mean, some point we'll do a vector search on usage patterns, right, to figure stuff out, right? Like it'll be the mode will be activity. It won't be video or image or something. It'll be activity. And you'll be like, oh yeah, that's the person I want to talk to. They have the same activities as me based on whatever it is that they do, right? So, but those kinds of things definitely are expressed through the vectors. I do think that hybrid is an amazing thing for right now, for the next few years. I do think, though, it's also a little bit of a band-aid in the sense that we're still leaning on keyword search for, various use cases. And if we were to look 10 years out, I think an ideal solution is that we're not doing hybrid anymore. We just have a better approach
to search.
Something beyond vector plus keyword, something better that still supports the zero results is the right answer. Some of these problems that using vectors gives us, right? We would have better approach. And not this slightly band-aidy, I have two different ways of searching and then have to wedge them back together.
Yeah,
but for now, hybrid's exciting.
Yeah, I like that. I like where you're going. I wanted to also, I wonder if you saw that blog by Doug Turnbull. I will make sure to link it, where he talks about RRF, reciprocal rank fusion. And he shows on a handcrafted example that, if let's say neural search brings relevant result to the top or few results, keyword lacks and doesn't. So it basically brings noise. When you combine the two, you will end up having kind of half noise, half signal, and it will look terrible. It will look terrible, right? And where do you stand on this? Like,
only matter. There was a way.
Yeah.
If only there was a way of better understand, not just blindly.
Yeah.
Blindly matching things. And I'll hand it over to Daniel in just a moment. I do want to call out, I really liked your previous episode with Alessandro, where I can't remember if it was you or Alessandro, but you kind of, I think it was you, Dmitry, said that your engineers were looking at hybrid search, and they kind of looked at it and said, when you strip away the fancy words like ranked reciprocal fusion for blending things together, you're like, that's just round robin, right? And round robin is not necessarily round blind, and it's blind round robin, right? It's not round robin in your middle school when you had to pick teams for dodgeball, right? The people picking knew who the best players were, so at least you were at least divvying the best choices, and at the very end, those last two kids, you knew they were the worst choices. They were the noise in the search results, right? But that round robin at least had the benefit of knowing what was good. Ranked reciprocal fusion has no sense of whether those results are good or bad, right? It is literally blindly picking them in some order with no sense of what that is. And as you can imagine, blindly picking is going to lead you potentially a very weak dodgeball team, right? And yet that's what we think of as state of the art.
Yeah. So Daniel, what should we do in this case? Is there any solution?
Yeah, Daniel.
It's a good segue into what we actually tried and explored and experimented with. So in our most recent work, we tried to come up with a systematic approach to optimize hybrid search, specifically in OpenSearch. So in OpenSearch, actually right now, you have linear combination techniques at hand. So that means you have two normalization techniques. You can choose one, the L2 norm, the min-max norm. They are basically both there so that you can normalize the scores from keyword search into the, let's say, space of vector search, so that you can compare apples to apples, more or less, and not apples to oranges, because as we all know, BM25 scores, especially if you have like wild field weights, they are unbounded. They can be in the dozens, the hundreds, the thousands. So you don't really know upfront in what range you are operating. And also you can't really compare the scores from one query to another query. So that makes it really difficult to combine keyword search scores with any other, let's say, search mechanism. Together with these normalization techniques, the L2 norm, the min-max norm, you have three combination techniques at hand. That's basically just three different means you can apply: the arithmetic mean, the harmonic mean, and the geometric mean. So that leaves you with 2 by 3, so that's already 6 parameter combinations that you can try on. And then you can define weights. So how much neural search weight, how much keyword search weight do I want to have in my query? They always add up to 1, so you can say I want to go with 10% keyword, 90% neural, or 50-50. Thinking of, let's say, 11 of these weights, so maybe you start with 0 keyword and 100% neural, then 10%, 90%, and so on and so forth. So that gives you a range of 11 multiplied with the 6 parameter combinations that we already had, gives us, let's say, a solution area to explore of 66 different combinations, which is pretty manageable. So we defined optimizing hybrid search as a parameter optimization problem. And we picked the most straightforward approach that you can pick. We just tried out all different combinations and calculated search metrics based on judgments. And then we just had a look at which one is the best combination. For our experiments, we used the ESCI data set. So that was released by Amazon a couple of, I think, 18 months ago, something like that, as part of a Kaggle competition. This data set comes with queries, comes with products, and most importantly, it comes with judgments. So we basically have everything that we need to really try out different parameter combinations, see how they work, what results are retrieved, can calculate a couple of metrics, compare these, and then see which one is the best parameter combination. And that's what we call the global hybrid search optimizer. So we try to identify the best parameter combination globally for all the queries that we are looking at in a certain defined subset of queries. So that's kind of the first step, the very, very straightforward approach that we applied. That's not really something let's say, scientifically sophisticated. Yeah, it was just a very brute force approach to see what's in there, and also learn how results maybe shape or turn out differently when we increase neural search weight or increase the keyword search weight. Which normalization combination technique is usually the one that's best to retrieve the results, and so on and so forth. So we started out with what I call reasonable baseline. So searching across, I think, 5 or 6 fields. So title, category, color, brand, description, some bullet points. So e-commerce data set, like pretty basic stuff. And we calculated our metrics with that baseline. So I would call it probably not the best baseline you can come up with, but a reasonable baseline you could come up with. So we didn't want to, let's say, just create the weakest baseline, because that's not really difficult to, let's say, outperform. So we wanted to create a reasonable baseline without putting, let's say, a man-year in finding out what the best baseline is. That scored okay, right? We got decent results out of that, and then we ran this global hybrid search optimizer, and that outperformed the baseline already across the metrics that we had a look at. So better NDCG, better DCG, better precision at 10 were, these were the 3 metrics that we had a look at. And that was nice to see, because that already gave us, let's say, assurance in, hey, there is a straightforward approach that everyone can use, because it's really easily applicable. It gets you good results, and it also gives you assurance that there is something to neural search when switching to it from a keyword-based search engine or search application to a hybrid search application. But as always, when you apply something globally, there are winners and there are losers. So some of the queries really improved by this hybrid search optimization step, the global one, but others didn't. So we took this one step further and thought about how can we really create a process that dynamically per query now predicts what the best parameter set is. And that now is also like going in this direction that Doug mentions in his blog post, right? So that's kind of a query understanding approach to hybrid search. So we're not just blindly applying one parameter combination that we identified on 1,000 queries that we explored. We are taking one query, analyzing this one query, and then saying, based on a variety of experiments that we made, what is for this individual query the best parameter combination that we can apply, so that we are not really globally applying something, but individually, dynamically per query. And to already maybe give you the results of what we did, and then go into detail how we did it. The dynamic approach outperformed the global approach. So we managed to identify a set of features. We trained a model, or multiple models actually. And by applying this, we were able to predict the best neuralness in that case, so the best neural search weight for a given query based on the results we got of the global hybrid search optimizer. So we basically recycled all the different search metrics on a per query basis that we got, did some feature engineering, trained models, and then used these models to predict what is the best neural search weight for this query. And with this dynamic approach, we even saw increases up to 10% in one of the metrics of the 3 that I just mentioned, DCG, NDCG, and precision at 10.
Yeah, that's very exciting. Thanks for sharing this whole, end-to-end picture or pipeline. I'm particularly interested, or at least at this point in time, about the fact that, well, first of all, your dynamic approach outperformed the global one, right? And that seems to be thanks to that query understanding part, right? Can you talk a bit more about that? Uh, and also, did you check those predictions manually? For example, does it make intuitive sense that system picked for that specific query, it picked more neuralness? I mean, is it like a natural language question there, or like some remnants of it, or is there some other interesting findings that you could share possibly?
Sure, yeah. So let's first maybe outline what we did exactly, and then dive into a couple of observations that we made on the way. So we started out by creating what we call feature groups, and then we created features for these feature groups. So we looked at three different feature groups. One was the query feature group, the next one was the keyword search result feature group, and then the semantic search result feature group. For the query feature group, we had a look at the length of the query, the number of query terms, if the query has numbers in it, and if the query has any special characters in it. So we kind of thought of ways figuring out when is a query maybe more specific, when is it more a broad query, a narrow query. And then we just came up with rules like, well, the longer a query is, the more specific it is. And maybe if we have more specific queries, we have less results. That's where we may want to augment search results with neural search results. On the other hand, when we have a very broad query, we may have a lot of results. These are short queries, and then we may want to, let's say, only use organic traditional keyword search results. Yeah, so we just came up with a couple of assumptions on our side, and then with these four features. For the keyword search result feature group, we looked at the number of search results, the number of hits we got when we executed the query with our baseline search configuration. So the one searching in the 6 fields. And then, well, something like, hey, if we have 0 results, then this is maybe a perfect scenario for neural search, because then we want to augment 0 results with 0 keyword results with what comes from the vector search application. The other two features we had in this group were the best title score we had in the keyword search result. So if we have a strong title match, maybe that's an indication of we don't need as much neural search. And we also had a look at, I think the average title score in the top 10 was another one. So if we have like a high average in the title scores, that's maybe a good sign for no augmentation needed with neural search results. For semantic search, it was similar to the title score. So we had a look at the best title score and the average semantic similarity based on the title that we had indexed. So by looking at these three groups, we thought of, well, we now have a representation of the query on its own, the result set based on keywords, and then the result set based on neural search. And that was kind of our starting point. And then we did loads of experiments having to do with what's the best feature combination when we train a linear regression model or a random forest regression model. What does regularization play for a role? Can we optimize the model training aspect with that? So we really did a lot of iterations with these. We also had a look at a large query set versus a smaller query set to see if that also provides different aspects to it. If we just randomly sample 500 queries versus 5,000 queries. We did a lot of exploration to really figure out and make sure that we are not really, let's say, randomly receiving the uplift that we saw, but actually really making sure that there is something to it, and that we can, well, go out in the wild, for example, on this podcast and share our observations and be kind of on the safe side that they can be reproduced, hopefully, in other scenarios as well. So that's kind of on the, let's say, how did we do it? The features, feature engineering, how we train our models. So we had a look at linear regression models and random forest regression models as a starting point, because we thought, let's have a look at simple models first. And if that works, we can still have a look at the more complex ones. And that's maybe already the first observation that I can share. So linear regression models, the simplest form, random forest regression, a slightly more complex form. And then this is the last model iteration that we did last week. We also had a look at gradient boosting methods. And interestingly, they all were almost the same from the model performance perspective. So it wasn't like the most complex ones really give you the best results. And that's kind of a very reassuring feeling, because we need to calculate a couple of features, right, per query. And that adds latency to your query execution. And especially in e-commerce, where every millisecond basically counts, we don't really want to, let's say, run multiple queries to calculate our features, just to have like 0.3% performance increase. So it really has to be worth the effort. So that's kind of a nice observation. So we don't have to go for the most complex model architectures. We can stick with the simple ones and don't really lose a lot of performance, if any. The linear regression model and the random forest regression model, they actually scored absolutely equally when calculating the search metrics. So they predicted the NDCG scores slightly different. So that's how we did it. We predicted NDCG scores by adding neural-ness as a 10th feature in that case. And by looking at which neural-ness scored best, and that's kind of the neural-ness we went then with for our testing efforts afterwards. So that's kind of the first interesting observation that we made. We also had a look at different feature groups. So what happens to model performance if we focus only on query features or only on keyword search result features? So training models within one feature group only and not taking all features into account. The interesting part here was that the combination worked best. So not always the combinations of all 9 features together with the neural-ness feature, but at least some of the keyword search result features, some of the semantic search result features, and some of the queries features. So they work best, but looking at the query features only, and these are the simplest ones to calculate, they weren't far off, these models, from this performance aspect. So you wouldn't really lose a lot if you only chose query features for your predictions. So that was another nice observation here, that if you went with the highest performance in terms of, let's say, inference speed and also speed of calculating the features beforehand, you don't lose a lot of search result quality. So again, you don't have to go with the most complex approach to get reasonable results out of that, which was, I think, the second most important finding, at least from my perspective, because that gives us, again, reassurance that when putting this into production, we don't assume, let's say, hundreds of milliseconds added to your query latency if you stick to the simple features.
It means that there's like room for growth with this technique, right? We're not maxing out this technique just to get started. We can start out, and then as we get more sophisticated, we have room, we have milliseconds to burn to do other cool, interesting things.
Yeah.
Ask an LLM to characterize the query or something like that, right? We've
But
got room for growth.
but I also like this lesson, and I think it kind of resonates with what I've seen in, doing ML previously, is that start with like simpler solutions and try to kind of maximize ROI, by upgrading to a more complex one. And you need to set some
Yeah.
thresholds because, like, as you said, Daniel, just, adding 0.03 won't cut it, right? It's not worth, because also when you bring in neural search, it means that you need to build that parallel index of things, right? Like you need compute, you need
Correct.
maybe GPUs as well, and someone will will need to pay for it. Uh, and I guess
Asking Daniel when we were doing this project, I kept asking Daniel, I'm like, why is reindexing with embedding so slow? Like, where's my turbo button? Like, really? Why is this still a problem? It's 2024, almost 2025. Why does embeddings take a long time? I
yeah,
remain a little confused why it's slow. Like, don't
yeah,
we just turn a knob and make a GPU go faster, and then reindexing with embeddings is just the same speed as reindexing with keywords?
yeah. But also
Daniel
what
says no.
Daniel says no.
Math
But
is involved.
But also, like, the fascinating part, like, one thought crossed my mind as you explained it, Daniel, is that in some sense, you've built some sort of like a reasoning engine, if I may call it that way. Maybe it's not fully, reasoning like, I don't know, LLMs start to do it that way or something, but it's like the engine
Right.
that looks at the query and examines its features and makes some conclusions, and then it looks also at the results. It's not like
Yeah.
you understood the query, you send it over to the retriever side, and then you hope for the best, that there will be best results, right? But in some sense, you
Yeah.
you basically do this dynamic sort of reasoning on top of everything. But the lesson there you said, and correct me if I'm wrong, is that just by looking at the query features, you could already achieve good results. You don't need to look at the result features.
Right. Yes. Yes.
But wouldn't it be nice to look at those? Yeah. I do
Yeah.
love the idea of looking at both sides, right? We tend to focus on queries because I think that's the viewpoint of our industry. We are very query centric in the search world. It's all about the query and what can we get out of the query. We really don't look at the results that much, except to say, are they good or bad?
Mhm.
And we're not particularly good about factoring in and what did the user do back into our algorithm. And yeah, I love that this is a little the dynamic thing that we're doing here. I think is a pointer to bringing in more dynamic aspects to our algorithms where they actually can start evolving or changing or being very specific to very specific query types, use cases, time of year, right? And today, that's very difficult to do. Only the most sophisticated teams have sets of algorithms.
Yeah, but I also feel like I like what you said, Eric, like looking at results, and reasoning about results, and also what you understood about a query might lead to much better final representation of what you show to the user, right? Because there is so many factors also beyond the query and results, right? Like as you said, season, or you observed some patterns with the user, the recent purchase history, and so on and so forth. Yeah, I mean it's very fascinating, and also like if I continue to draw this analogy with LLM world, when you ask LLM to think through what it has done, it may
Yeah.
correct
Mhm.
itself, right? By just looking at what it has produced, because LLMs are, as someone said, calculators for words. So if you give it itself its own output
They
and
have
and
state,
ask, yeah, exactly,
right?
yeah,
Like, I can't wait to write a search algorithm that understands what they did the last time. The user didn't like the results. And so when you get a similar query for the same user, do something new, right? Try
Mhm.
something new because whatever you were doing before, the user didn't like. You know, joke about if the user hates what you're giving them, you might as well just return random docs because that'll be better than whatever you're doing right now, right?
yeah, yeah. At least you have a chance there, right? With random
So one
selection.
question I sort of have though, in what we described, how is it different than learning to rank? Other than learning to rank is about ranking one list, and here we're ranking two lists. Is do I just conceptually have the role of learning to rank wrong between what learning to rank is and how the dynamic hybrid optimizer was working?
So, I mean, we are not re-ranking results, right? So that's what typically learning to rank does. But what we are kind of doing is we are learning when to, let's say, increase the weight on keyword search results or on neural search results, right? So it's kind of a
Blend?
learn to blend, learn to search hybridly.
LTP, the new technology, or are we just done with the learning to uh, nomenclature, right? And we like optimizer better than learning to blend.
Maybe, yeah. So I'm not the one who's most creative in coming up with clever names. Yeah. So maybe it's time for not learn to, but blah 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 optimizer, and that's kind of how we ended up with the hybrid search optimizer right now. But I wouldn't really have a good let's say, argument against calling it learning to optimize hybrid search or something like that, because that's kind of what the dynamic approach does, right?
As we gather more data, more clicks, more of that, those go into the features, right? We even use the language of learning to rank, right? Feature engineering, yep. Right? We use that language and we're building a model. And you even mention, right, linear models in a forest, and those are all the words that I think of as, oh, it's learning to rank. So interesting. I think it's interesting to see learning to rank maybe come back in a new way.
I mean, learning to rank is still something you can apply on top of the hybrid search optimizer, right? So it's not like we have any kind of substitute here. So that's kind of still, I think, a very valuable tool in the mix. And that's just now one way to really figure out what's the best way of getting to reasonable hybrid search results.
Yeah, but I was recently also thinking about this. I wonder what's your hunch on that, but learning to rank sort of depends on the training data, and you usually collect it from the past. You don't collect it from the future, right? And so as you move into the future and patterns change, you carry over that past weight that can actually go against the intent of your reasoning engine. And that's where I think that a lot of work needs to go in all of these directions. But as you optimize your retrieving and your reasoning engine, your query understanding, maybe you should dial back the LTR a little bit, or maybe you need to retrain it right there, right then. I don't know, or retrain frequently enough so that you don't lose the invention strength, right?
Yeah. I think that's our challenge in a lot of these things.
Yeah.
That are the historical approaches versus the predictive approaches, right? Yeah. And which ones do you go with, and how do you discount the historical if you have a bunch of new interesting data?
Yeah. But I also like the limitations of the physical world. I think from investment books I've read, one key takeaway lesson is that no one can predict the future. If someone claims that they can do, they probably lie. But again, I guess there is still room for being more dynamic. And is there something you guys wanted to also show? I mean, is this something we can look at visually, or?
Well, theoretically, we can.
No pressure. I mean,
so this small demo here, and I'm going to show the results first and then how we get to these results. It basically takes in a user query. My search application now is this Jupyter notebook, so it's not the most sophisticated search application, but it calculates the query features, then with these query features reaches out to the model to get the best neural nets for these search features. And with that retrieved response, the query is built together and then sent to OpenSearch. So we're just going to have a look at a couple of examples first, and then we can have a look at the code. So again, this is now part of the ESCI data set. My index has like 20,000 documents in it, so it's not large. It's only a subset of the ESCI data set. And when we send queries, now in this case, waterproof jacket, in this method, the method first, as I just explained, calls out to the model. It retrieves the neural net score and then builds the query together. And then we have this HTML display here. As you can see, there are not images available for all of the products, but what we can see here is that weatherproof jacket, it gets a 50-50 search weighting. So in this case, 50% keyword, 50% neural. If we go for weatherproof jacket for women, the weights change. So now we have 90% neural and only 10% keyword search weight.
And Daniel, and that's because the query became much more specific, meaning that since we did add women there, we are not expecting results for men or for kids, right? Is that
exactly? So that's kind of what we can now infer maybe in what the model picks up. Yeah. So we have a longer query, we have a more specific query. So it's not really looking at the words per se, the model, but at the features like query length. Are there numbers in it? Are there any special characters in it, and so on? So another one, weatherproof jacket black, and we also see that maybe results that we wouldn't really expect are in the top here, but again, it's only a smallish proof of concept kind of thing that we are looking at here. But we can see different queries that are similar from a, let's say, meaning standpoint of view. They retrieve different weights in that case. And that's kind of the interesting thing. We can go for something completely different as well. iPhone case. And we see like nice iPhone cases throughout the query, and that goes with neural 0.7 and keyword 0.3. And I don't know what's iPhone 15 Pro Max case black. So that would be a very, very specific query. And here again, the neural search weight increases. Whereas when we go for a very broad query, so that's maybe one characteristic of the model that you can almost feel is the more specific we get, the more neural weight it gets, but also other features do play a role.
Yeah, that's very interesting.
And that's how the OpenSearch query looks like. So let's say the interesting part is that one here. So we have a keyword query, which is, like I explained before, searching in these couple of fields with different field weights. A best fields query multi-match with the AND operator. And then we have a neural query that retrieves the K100 based on the title embedding that we have. And then the hybrid part is actually the search pipeline that normalizes, in this case with the L2 norm, and combines the results with the arithmetic mean based on the keyword search weight and neural search weight, and that are here passed in as variables that another method predicts with model inference in that case.
Yeah, very cool.
That's kind of the small but built-in Jupyter Notebook prototype that we have. Everything we build is, like Eric just mentioned, open source. So we have a public repository that contains all but this one notebook, actually, but everything you need to train the models, do the feature engineering, calculate the search metrics. So yeah, everything you actually need. So running this with the ESCI data set is possible for everyone. And if you want to apply it with your own data, that of course is also possible. So that's kind of what we are looking at next. Yeah. So adoption in the industry and also hooking it up with the other part of this project, which is namely the, let's call it the evaluation part, calculating implicit judgments based on user feedback, so clicks, queries, stuff like that, so that we also enable not only everyone to optimize hybrid search, but also enable and empower everyone to, well, come up with judgments if you don't have any, because that's kind of the basics you need for any query tuning.
Yeah, and that's where Cupid comes in. Shameless plug.
So one of the things, we actually have a reference implementation. Some of y'all may have heard of Chorus, which is reference implementation for e-commerce search. We did it in Solar. We have an OpenSearch version. And some of the stuff that you're seeing is sort of bleeding edge, hot off the presses. But we're working right now on getting the Chorus for OpenSearch edition updated with some of these scripts and notebooks. So you can just check it out, run the quick start, and then have everything and start playing with it. So you don't have to build all the steps yourself. So you can see how all the pieces fit together. And so that's available. It'd be great if we could add a link in the liner notes for that as well, Dmitry.
Yeah, let's do that. And just wanted also to understand this search pipeline and all this, mechanics of hybrid search that you guys implemented. Is it like a plugin to OpenSearch? And what's the plan for it, right? So I guess you spoke to that, like let's give it to as many users as possible. What's your idea there?
So hybrid search is available in OpenSearch. So with let's say the basics here, so you can create a pipeline and say 70% keyword search rate and 30% neural search rate. You can also define these on the fly, but we currently have the limitation that we, although we can hook up the model within a so-called ML inference pipeline in OpenSearch, this ML inference pipeline can, as of now, not pass the predicted neural and keyword search weights to this pipeline. But feature request is already out there, and I assume that in one of the next OpenSearch versions, we will have the possibility to not only, what's already possible, hook up the model within OpenSearch so that it from within OpenSearch, you call out to the model to make inference. You retrieve the predicted neural and keyword search weights, and then you can use these in your search pipeline. So there is already an implementation plan out there. There are open feature requests, and if anyone wants to give these a thumbs up to prioritize that within the OpenSearch community, that would of course be greatly appreciated. And I'm sure we can include these GitHub issues as well in the show notes.
Yeah, for sure. Let's do that. And we will call out. That's our call out to the community. Please vote if you care. I hope there will be enough people who care about this.
Fingers crossed.
Yeah, exactly. And then you said everything is open source. Does that mean that the training scripts, the algorithms, the choices you can make there is also open source, right? And we can link to that as well. Yeah.
Yes. So everything we did, I mean, we of course didn't include all the 1,000 experiments, but all the helpers at least that we used to run these 1,000 experiments, they are all in the repository out there for everyone to have a look at and maybe come up with even better ideas than we had. So we definitely always love to hear these as well.
Wow, this is
Yeah.
amazing. This is like in true sense, you speak up to your name, open source connections. That's amazing. Like to me, it's a ton of work that you could choose to hide as well, right? And work only with your clients and nurture and iron out and everything and make a ton of money and continue on that. But you choose to open source because you believe in the power of the community as well to enhance it. That's amazing.
Well said. Well said. So
So what's next? You already said a couple of words, but what's next? And also, do you want to address our audience? What do you expect from
yeah,
them?
I mean, I think one of the things is as we've gotten into this, we found some rough spots in OpenSearch, right? OpenSearch has a strong ML component, ML Commons project, right? But integrating it in sort of new and interesting ways, like what Daniel was showing, we're finding some rough spots. It is interesting to me. It does bring to mind the do search engines, what we call a search engine, need to evolve to be more of an ML engine as well, right? I mean, it feels to me like search has been revolutionized by machine learning. And as we move into this direction of more calculating, building models, evaluating data on the fly, do our search engines need to support those use cases and go beyond just the I get a query, I get documents, I match them up, and that's it, right? Is there another layer of computation that we kind of need in the search engine versus bolting it on in some other environment with an ML ops pipeline and all the rest? And I think that's an interesting, one place where I think OpenSearch is a little bit, is definitely breaking some interesting ground is all the machine learning aspects to it. But data processing and building models and all of that needs to maybe be a first class citizen of what we consider a search engine versus something done by some other system elsewhere, because that's a lot more complexity and raises the barrier to adopting these things. So I look forward to things like a hybrid optimizer just sort of being like what you do when you build your search engine. Of course you turn on the hybrid optimizer if it meets your use case and you have the judgments and other features that you need, right? Versus a major engineering project that we're going to do that's going to take us 6 months. So yeah.
Yeah, yeah,
Um, and supporting that, as Daniel highlighted, the search quality evaluation framework that we're adding to OpenSearch is really exciting. Would love to come back, Dmitry, and talk all about that on another show.
yeah. Let's do that. I'm really excited to dive deeper into eval because I think in so many ways you need to start with eval, especially if you have a search engine already out there, to establish that baseline for yourself, and then learn and introspect where things
And
work or fail. Yeah,
make sure some of these models don't go and produce terrible,
yeah,
batshit crazy results, right? We have the risk that boosting up on neuralness might be terrible, right? And we have to
yes,
understand that. And so we need to be much better about evaluation, right? We can't take our eye off the ball of speed, right? Query speed does remain just sort of top of mind. We also really need to be good at evaluation. And I think for a lot of search teams, that's kind of a new thing.
yes,
And that's why
absolutely.
there's so little tooling in most search engines.
Yeah, and we do want to be
One other thing I
cautious.
want to shout out. Yeah,
Please.
one other thing I want to shout out is that the next Haystack conference, the save the date last week in April, right? Last week in April, save the date went out, and we are looking for talk reviewers, people who want to be reviewing the talk proposals. It's a double blind process. We get a couple people from the community. So if that's something interested, reach out to David Fisher. He's running that process. And the call for proposals will be out. I'm curious if this year Haystack in Charlottesville might as well just be called Hybrid Stack. Like, are we going to have 2 days of talking about hybrid? Because RAG is, that's last year. Now we're on to hybrid. Or is there going to be something new? So it's going to be interesting to see what what kind of comes out of the community for this year's Haystack.
It's also very interesting to see this dynamic or this evolution because I think 2 or 3 years ago, hybrid search was at the top of charts. Everyone was discussing it, and then RAG superseded it. And that just tells me that maybe we didn't dive deep enough into the topic. We just let it go. It passed, and people thought, "Oh, that doesn't work. We need something else." And now it's RAG, RAG, RAG everywhere. But then RAG also comes with its own, limitations.
Yeah.
And now we have a new, evolution level, right? With hybrid search, you guys are optimizing. That's amazing. I was actually waiting for it. I'm happy to see it happen. And thanks for sharing the story. Let's come back to the eval when you guys are ready. I also expect that you will publish some blog posts around this topic, about this topic. So I'll be happy to promote those as well and read them, of course, and learn.
Terrific.
Yeah.
Excellent. Thank you.
Thank you very much. Thanks for coming to the show today and sharing this story. It's very exciting and also showing the demo. I like notebooks because they allow you, to quickly dissect things and have a feel of what's going on. I'm glad that Eric still uses the cup that we gave him as a gift.
I love it.
It's
great.
like you rarely see the gift you gave like coming back and saying you did this and the person you gave it to is still enjoying. That's amazing.
So awesome, Dmitry.
Thank you
Great
very
to
much.
see you. Thanks for having me and Daniel on.
Yep,
Yeah.
thanks for having us.
Yeah, thank you. Take care. Bye bye.
Bye.